Hi, I thought I would make a quick video on what actually happens when you are creating a supply chain and optimize it. Optimizing means you are trying to reduce the cost or increase the profits, okay? So as with anything else, any supply chain should start with the customer's demand. So let us say that there are two different customers, one customer in Cleveland and one customer in Columbus, okay, or a group of customers in Cleveland and Columbus. Let's say there is about 200 packets of churros are in demand in Cleveland and 500 packets of churros are in demand in Columbus per week, okay? So we have to make sure that we supply 700 packets to Cleveland and Columbus on a regular basis. So you end up calculating what it would cost for you to, ask one of your distributors in Akron, and let us say you are in Grove City. Here I have kind of, created different numbers. Now the thing is, you can change any of these numbers, okay? So you are estimating these numbers based on your existing information. Similarly, you are also estimating your demand for churro packets, okay? And you can always change it to say 250. What happens if it's to change, or 550, okay? So let us just stick with 200 and 500 just for simplicity purposes. Let us say that you have two warehouses. That is, one warehouse you are working in Grove City and you can sell it from Grove City, and it costs you about 35 cents for you to store it there. Whereas in Akron, it is also the same storage cost of 35 cents. You can very well change it to 40 cents, 45 cents. Okay, we will do that later. Now, in terms of transport cost, obviously Akron is close to Cleveland, so we are putting about 20 cents per mile. So this is dollars per mile. Whereas if you take it from Akron and take it all the way to Columbus, then it may cost you, say, 55 cents a mile. When it comes to Grove City, it is close to Columbus, so I put 20 cents there and 55 cents. And you can very well change it to 0.25, and you can put this 0.3 and this one as 0.65. You can do anything you want. Now, just for the sake of simplicity, we will keep it simple. Okay, now the question is, we have to decide whether we are going to use the Akron warehouse to sell to both Cleveland and Columbus, or Grove City to sell to both Cleveland and Columbus, or whether Akron will sell only to Cleveland and Grove City will sell only to Columbus, which is probably the reasonable thing. Since we don't know how much we should be sending to each and every one of these places, so Akron to Cleveland, Akron to Columbus, Grove City to Cleveland, Grove City to Columbus. So these are the things we need to decide. So we call them as decision variables. Okay. So we have to choose how much we are going to produce or transport from these warehouses to these customers and meet the demand of, say, 200 in Cleveland and 500 in Columbus. Right now, we don't know. So I just put 111. So very well we can do this. For instance, you can put 50 to Cleveland from Akron and another 150 from Grove City to Cleveland. Otherwise, in Columbus, we have a total of 500 demand. Akron can sell about 300 and Grove City can do 200. Okay, so if we were to do that, yes, the total supply to Cleveland is 200, total supply to Columbus is 500. We are meeting the demand for those two places. But at the same time, if you look at the cost is, say, $542.50. Okay, it's quite expensive. The question is, can we reduce it somehow? That is the big question. And that is where we can use something called a solver. So how do we open it? Go to data and go to solver. Sometimes the solver may not be there and you will have to go to file. Under options, you have to open the add-ins. Okay, under add-ins, you will be able to add in all the different things that you would want. I believe you have to add the analysis tool pack, and we already have it, so we are not doing it. Once you do the analysis tool pack, the solver will show up. And once you go here, it's asking, okay, what do you want to do? We say that, hey, you know what? The cost of $542.50, that is what we call the objective function, the total cost, is too high. we want to minimize it. So click on minimize. You can either maximize or minimize. Obviously, this is cost, so we want to minimize. If we are calculating profits, then we will click on maximize. Okay, we don't want to maximize, we will minimize. By changing what? These cells, that is how much of product will go from Akron to Cleveland, Akron to Columbus, Grove City to Cleveland, Grove City to Columbus. So these are the four things. Oops, I made a mistake. It's actually all the four. So you select them. Now we need to make sure that we meet the constraints. So what are the constraints? The one constraint is that the demand that is in B7 should equal the supply that is K7. Okay. So this is the demand for Cleveland and this is the demand for Columbus. Both have to be met. They are equal to each other. Once you do that, you just click on solve and immediately it tells, hey, you know what? There is a solver solution, and according to the new solution, Akron should sell to Cleveland full and full 200 units, and Grove City should sell to Columbus 500 units. Okay, so we are just going to say yes, that makes sense. Now let us go ahead, look at the total cost. Hey, it's only $385. Earlier it was like 542 or something like that. Now it's only 385. So we have been able to reduce the costs by picking the right amount of quantity that we want to move from, say, your distribution center in Akron and Grove City to the customers in Cleveland and Columbus. And this is exactly what we call as optimization. Okay, optimizing is all about minimizing cost or maximizing profits. Now, it's the same thing that happens in any logistics software as part of your supply chains course or as part of anything. Okay, here I put a very simple example, but in real life, in real world situations, it can be a lot more complicated. They won't be using these type of Excel and simple spreadsheets, but they will use very advanced software. Okay, so let us change it up. Okay, and I already told you that we can use this to find the differences. For some reason, let us say your Akron distributor is very difficult to work with and they are charging you a high price of 55 cents per unit. Okay, and in Grove City, the costs are cheaper because you figured out a way to store them more effectively, something like that. So costs have gone down in Grove City. And you also decided that you are going to invest in an electric truck and you can drive from, and you live in Grove City, let's say, and you can drive all the way to Cleveland and Columbus. And your costs are only, say, about 42 cents to come to Cleveland, and it's only 18 cents to go to Columbus. Okay, and all other things are exactly the same. Now let us see whether the same distribution of, Akron selling all of it to Cleveland and Grove City selling all of it to Columbus still is the case. So how do we do that? So go to solver. Again, set the objective. Objective is actually $390 that we had earlier if we were to do it in that same manner. And now what happened? So the prices have changed because your transport costs have changed. We want to reduce this total cost, minimize it, and by changing the cells of Akron to Cleveland, Akron to Columbus, Grove City to Cleveland, Grove City to Columbus, by meeting the demand. Once you do that, click on solve, and what happened? Hey, things changed. Did you see that? Now Grove City is so cheap, you should be selling even to Cleveland from Grove City itself because Akron is not cheaper anymore. Now let us go ahead and see. You are able to reduce the cost by, say, from $390, you are able to bring it down to $384. Okay, so you are able to achieve cost efficiency or minimum cost by changing your decisions. Okay, now there is one another thing that you need to notice. So what did we just do? We changed these numbers and accordingly the results also changed. Now there is one another thing that you need to be aware of. When you code these constraints and variable cells and objective functions, you need to make sure that you don't maximize it. If you maximize, then you will end up maximizing the cost. We don't want that. We want to minimize by changing the supply from your distribution centers in Akron and Grove City to Cleveland and Columbus. Now, with regard to the constraints, let us say we don't have the Cleveland constraint, okay? Only the Columbus constraint is there. Then if you were to do this, what happens? Yes, you have been able to do that, but you removed the constraint related to Cleveland, so the Cleveland customers were not sold at all. They got only 0, and all the Columbus customers got served from Grove City, but none of the Cleveland customers got served at all. Why? Because you removed that constraint. Okay, so that's a mistake. Now you can add the constraint. You can make sure that you can put that by saying that, hey, you know what, there is a demand of 200, and the supply, or I should put it as the supply should equal demand, right? So we will put the supply should be less than or equal to the demand, like that. And the demand is, say, 200, okay, in this case of Cleveland. Now what happened is, the thing is, earlier I had it as equal to, so the supply should equal demand, but now what have I done? I have written that the supply should be less than or equal to the demand. So if I were to do this, this is also a wrong solution. In this case also, you will be getting a wrong answer because you said the supply has to be less than that of demand. So 0 is less than 200. Okay, so that's a mistake. In that case, how do we correct it? Again, you go into this particular, ouch. So click on solver and click on this and change, and it is not less than or equal to, but equal to. When you do that and then you solve it, then you will get the right number, and in the right number is actually $384. Why? Because now you are meeting the demand for Cleveland customers and the demand for Columbus customers. 200 is equal to 200 and 500 is equal to 500. You see that? So that is how. So this is how you will go back and forth. So by changing all these numbers, you will be able to achieve whatever you are trying to do as part of your optimization. So you have to learn how to do optimization, okay? And this is something that all the supply chain students should be aware of, and you have to learn that as well. So again, you figure out your demand, and you can change the demand 200, 500, and Akron and Grove City, their transport cost and storage costs, and then you have to decide how much you are going to sell from Cleveland to Cleveland and Columbus from Akron and Grove City. And right now we are not meeting the demand of 200, 500. We are meeting only 2 and 2, and you just go to solver and you set it up by calculating the total cost, minimize it by changing the cells while you are taking these constraints into account. And you click on solve, and there it is. You have achieved your goal of supplying to Cleveland and Columbus customers. Cleveland customers only from Akron, Columbus customers only from Grove City, and your cost will be $425 for these numbers, okay? And you can very well change it, and you will get all different numbers, so you can play with it. So this is how the optimization models work, and I want you to understand the basic behind it. So this is the, the bare bones version of what is happening under network optimization in the any logistics software. Now the same thing happens at a much larger scale for 5 different distribution centers and 500 different customers all across the country or all across the world. So that is how this thing works, okay? I will see you some other time for some other video. Thank you.